Hello, good morning. Welcome to the lecture series of power system protection. The power system protection divided into 5 modules. In module 1, we will learn about the elements of power system, function of protective relays and protective zones, primary protection, backup protection, some desirable qualities of protective relay, basic terminology, and types of relay such as electromagnetic, induction type, thermal type and gas actuated type. While in module 2, we will deal with different types of relay such as overcurrent relay, differential relay, distance relay, comparators and static relay and their types. In module 3, we will learn about the different types of protection scheme for transmission line such as overcurrent protection, distance protection, pilot wire protection, protection of bus and bus bar, carrier current protection and concept of auto reclosing. In module 4, we will see some technical problem in implementation of protection scheme and their solution. Problem like restriking voltage, current chopping and solution like resistance switching, capacitive current chopping, different ratings of circuit breaker, testing and testing procedure. In module 5, we will deal with protection of operators like transformer, generator and motor. After that, we will see the construction of different types of circuit breaker and their rating such as oil circuit breaker, vacuum circuit breaker, gas circuit breaker, also known as SF6 circuit breaker. Let us start with the simple layout of power system. As we know, we can divide the power system into 3 parts. First one is generation, second one is transmission and third one is distribution. Since power system network cover thousands of miles and its largest man-made dynamic system, in such a large system, fault can be occur on generation or transmission or on distribution. Unfortunately, faults are inevitable. Only we design a system with proper protection. If we talk about the types of fault and their frequency of occurrence, fault may be occur on overhead transmission line, underground cables, switchgear including CT and PTs, power transformer and miscellaneous. In miscellaneous, we will count auxiliary equipment, the frequency of faults on overhead transmission line lies between 50 to 60%. For underground cable, it is 10 to 15%. For switchgear including CT/PT, it is 10 to 15%. For power transformer, it is 15 to 20%. And the last, for miscellaneous, it is 10 to 15%. By seeing this data, we can say on transmission line and power transformer lies between 70 to 80%, which is our main concern. Now, if we focus on line faults, it may be open circuit fault. It is also called as a series fault. And short circuit faults also called as a shunt fault. The open circuit faults may be occur by 3 means, may be 1 conductor open, 2 conductor open or 3 conductor open. And short circuit faults divided into 2 parts. First one is a symmetrical and other one is a asymmetrical. Symmetrical faults also called as balance fault because after the fault voltage and current phase are not disturb. And asymmetrical fault, also called as balance fault, because after the fault voltage and current phasor disturb. Symmetrical faults also divide into two parts. It may be a three-phase fault or three-phase to ground fault. While the symmetrical faults further divide into three parts. First one is single line to ground fault, second one is line to line fault, and third one is double line to ground fault. If you talk about the severity of faults, the three-phase fault is most severe. But if it's occur on the terminal of generator, then single line to ground fault is more severe. So when we design a protection scheme for power system, we have to keep all this point in our mind so that we can design the best scheme. Now if we focus on shunt fault, as we know the fault frequency is 50 to 60%. And let me scale it on 100%. Then the frequency of single line to ground fault is 70%. Line to line fault is 15%. Line to line ground fault is 10%, and for three-phase fault it is 5%. Now we see the way faults can occur. It is a simple transmission tower in which this one is a cross arm, topmost conductor known as earth wire, and this is our main conductors which transmit the power. This is known as insulators, and each disc of insulator may be bear 11 kV. Sometimes we use a jumper to connect two conductor or two lines. If jumper breaks by any means, it may be considered as open circuit fault. If one of the line break and fall on the ground, it is considered as single line to ground fault with high impedance. Let us see a video of a single line to ground fault. Let me explain to you. So this is our conductor, and due to arc and fire, insulation of insulator are punctured, and with the help of arc, this conductor is directly connected to the tower, and tower is directly connected to the ground. As a result, a low impedance single line to ground faults may occur. Moreover, some places tree are near the lines. Maybe one of the tree falls on the lines and may be cause line to ground fault or double line to line fault or three-phase faults. Let us understand with a video of three-phase faults. It is three-phase fault. Now, if we discuss the cause of electrical faults, it may be weather condition and we cannot control on it. It may be lightning strike. As a result, dielectric strength of insulator get damaged and line to ground fault may be occur. Next, heavy rains. Due to heavy rains, a conducting path available between two lines or conductors may be cause line to line fault. Third one is salt deposit on conductor, and last one is snow and ice accumulation. Let me draw a conductor and ice accumulation on it. Due to accumulation of ice, weight of conductor increase. Since effective area of conductor increase, hence wind effect also increase, and due to weight, sag also increase. And the next cause is human error. We can minimize it. And next one is equipment failure. It may be due to aging of equipment. Now we discuss harmful effect of faults. Heavy current due to fault may be cause fire or explosion, and also may be damage some of the elements of power system. Also arise the stability problem and may be cause of complete shutdown, also known as blackout. Heavy current also cause overheating and may be damage the insulating property of equipment and set up abnormal mechanical forces in apparatus. Before ending this lecture, let me discuss some important terms regarding the transmission such as feeder, service main, distributor, etc. This is a simple layout of a power system network, and the network have main substation, and a local substation. The conductor or line which are connected between main substation and local service station known as feeder. It may be on 11 kV or 66 kV. The conductor which carry power from local substation to near surrounding, such as industry or our houses, known as distributor. It may be on 440 volt or more. And the conductor or line which carries power from tower to our house, known as service main. And the conductor or line which carries power from generating station to the main substation, called as a transmission line. It may be on 800 kV or more. I hope you all enjoy the lecture. Thanks for watching.